This job by a super chemist. First thing I want to do is go over my apparatus. I just set up like refluxing. See how I got my water condenser here. Up on top I have a drying tube, calcium chloride in that's anhydrous. Down here I'm going to put my magnesium in. And then I have this separatory funnel, or equalizing funnel rather. I'm going to put my diethyl ether and my alkyl halide, which in this case is ethyl bromide. I'll put that in here, and I'm going to drip it in. Okay, this isn't the apparatus, but I wanted to say something that's in the video there. That's equalizing funnel that had the ethyl bromide in it and the diethyl ether. I was going to drip it into the magnesium metal, but I also should have had diethyl ether in there. I didn't put it in there though because I was cheap. But anyways, I already did that. When you drip that ethyl bromide into the magnesium, it makes your Grignard reagent, okay? And I already did a video on that, okay, called ethyl magnesium bromide Grignard reagent synthesis, okay? And this is a continuation of that video, okay, because you can't hold your Grignard reagent. Once you make it, you use it. You can't wait for the next day or a week later. So basically, I already dripped it in. I let it reflux for a half hour, and now I need to switch the hose over. Take the sep funnel out, equalizing funnel, and put the hose in its place so I can bubble the CO2 into my Grignard reagent and do a Grignard reaction. Now this part over here, right? If you watch my anhydrous, how to make anhydrous carbon dioxide, I should, this is the same exact apparatus. I have my baking soda in here. I'm going to heat it up with an oil bath. It's going to come up here just like a Dean Stark apparatus. It can't get past this condenser, right? The water, it'll drain back down. Instead of it going into the pot, it'll drain into this little whatever, that capture thing there. It's going to capture stuff. Then of course it goes, the carbon dioxide can get past there, right? She'll never liquefy it. Goes up to this hose, comes back down to this 3-neck round bottom flask. I have again anhydrous calcium chloride in there, so it'll dry any remaining water that made it past the condenser, right? Go through this tube into this. This is just a suck back trap right here, okay? And the tube goes down. Right now it's just going into this bottle here. But what I'm going to do is, after I fill this in, after the equalizing funnel is empty, all the ethyl bromide is in here, then I can switch this out. I'll take this equalizing funnel out, and I don't know if you can see, but there's actually a hose inside here. It'll go all the way down to the bottom of this flask here. Okay, I let it reflux for a half hour. And now I'm going to change out the funnel with the tube. Since I'm starting to make the carbon dioxide, I'm going to have to turn this one on too. I basically got both of these in series. See, it comes through here, and then it comes over here. That way I just use one pump. Now I'm going to turn on the oil, and I already told you about the carbon dioxide. I'm going to go through here, the hoses, all the way to this. See, I got this hose coming in, goes down to here, and you can see there's a little tube inside there, goes all the way down to the bottom, right there. It's already starting to boil. Bubble. That's it. I'm just going to bubble that for probably an hour or until, it stops bubbling. It comes out of here. It's up here, down here, and it goes into here. So if it gets a suck back effect, there's nothing in there. Right? It's an empty jar. It'll get sucked into here, and it can't go back into here because there's no tube. So it'll be stuck here, and that way it won't go, be destroyed by going into something like that or going into the actual pot. There's the pot. It goes up here, and here's where the condenser is, right? There. Now, even though the pot's only at 32 degrees, so nothing should be refluxing, you can see here. See that? It's refluxing. The reason why is because I'm bubbling all that CO2 through. It's carrying some of the vapors with it, some of the diethyl ether with it. So you have to have this condenser still going, while you're bubbling this stuff in. And at the very end, what I'm going to do is I'm going to put a hot water bath on this pot right here, right here. I'll put a hot water bath on that and let it reflux while I'm bubbling in the CO2, like the last 15-20 minutes. I'll reflux it, maybe even a half hour. I'll reflux it for a half hour while I'm still bubbling in the last bit of CO2. Been about 45 minutes or something. You can see it's 36 degrees. It's actually 36.6 Celsius. So this must be slightly exothermic here, adding this CO2. So I'm not going to reflux it at the end, like I said I was going to do. But I wanted you to notice something here. Look at all these little spots and stuff on here. See that? They're getting thrown. It's getting thrown up by the, the refluxing. I'm guessing. I don't know for sure, but I'm guessing that is because it's white. I don't think it's the magnesium. I think it's the tetrahedral intermediate salt that is formed, and so that's a good thing, I think, because that's my product. And then when I do my workup and quench it, it'll make it'll turn that salt into the acid that I want, propanoic acid. But I thought that was, interesting how there's white stuff here and I'm making a salt, so I'm hoping that's the salt. Now, when I made my GRIGNARD reagent, I didn't put any diethyl ether in the magnesium, which was a big mistake, because it acts as a heat sink, and, it's just you should put it in there. But I didn't have enough, and so I was a cheapskate about it. Same thing with this reaction. I didn't use as much diethyl ether as I should have, so there should be more in there, right? If there was more in there, I don't think that salt, that tetrahedral intermediate, which is a alkoxide, I don't think that would be precipitating out like that. I think it would be dissolved in the ether. I think that's the way you're supposed to do it, although I'm not sure. But I don't think that would be happening if I had put as much diethyl ether in as I should have. And this bites me later on at the end of this video. You'll see that it actually solidifies because there's so much solid in there. And but actually it was no big deal, because when I added the acid to quench it, it all, it broke up. Well, it's been 2 hours, but it's still making white stuff. I'm guessing that's my product. You can see it floating on top. It's all on the sides. This isn't metal, it's white stuff that was made. Well, keep bubbling it in, I guess, for another half hour, and then I'm just going to say screw it. It's 2 and a half hours. That's long enough. Just seems like it's making more and more. Just seems like it's making more and more. Nothing's bubbling through anymore, so I'm going to take this. Whoa, did you hear that? I'm going to take this and put it like this. I don't want it to get any suck back. You can see there's stuff in there. Now we're going to have to quench it. Okay, the density and the molarity of hydrochloric acid, I got this from Wikipedia, and this is for 10%. Alright, a solution of 10%. So what do? I take 1,000 milliliters, because this is per liter, right? There's 2.87 moles in 1 liter. There's 1,000 milliliters in a liter, so I divide it, right? Let's pretend this is 3, okay? So that means there's 3 moles in a whole liter. If I divide it by 3, that's 3 parts, and if there's 3 moles, that means each part has a mole, right? So I divide it by the 3, and I get this. 348 milliliters. That means if I take this times this, it'll equal that, right? Because that's how many, let's say 3 times that equals that. So this must have 1 mole in it, right? So we also know that concentrated hydrochloric acid you get at the store, like Lowe's, has a little more than 1 mole in every 100 milliliters of acid. So what am I going to do to make my 10% hydrochloric acid? I'm going to get 100 milliliters of acid concentrated that I got at Lowe's. We know there's a mole in it, right? Now how much? This is what you need for 10% solution. You need to have this much liquid with 1 mole of HCl. So what I'm going to do is I'm going to take the 100 milliliters, I'm going to pour it in half of this, okay, because this is 348 afterwards. When these mix, you can't mix volumes like 2 plus 2. It doesn't work out that way. So you have to add a little bit of water, add the acid to a little bit of water, and then add more in to make it go all the way up to 348 milliliters. Then you will have your 10% solution. A third of it I'm going to use to quench, a third of it to destroy the magnesium metal that's left over, and a third of it to wash the ether. Although this last third I forgot to do with that, so I still have the third of hydrochloric acid I didn't use. So we'll make my 10% hydrochloric acid. I have 90 to 100 milliliters of concentrated hydrochloric acid here, 100 milliliters of cold water here. I'm going to mix them together. Then I'm going to add more water so that this goes up to 348 to 350 milliliters. Okay, that way I'll know that it's 10%. I'll put this hydrochloric acid in the ice box, took it down below 0, and I split it up into three almost equal parts. You know, I'm not being exact about it. We only made a third of a mole, remember? We didn't make a full mole. So, and we made a mole of HCl though, remember? So this is a third of a mole right here. So that should equate to making our tetrahedral intermediate into the oh no. It's froze up. I should have moved more diethyl ether, but okay, well, I'm going to pour it into here then. Oh crap, it's boiling. I forgot about the magnesium. Since the magnesium's in there, when I put the hydrochloric acid in, it's making hydrogen. The hydrogen is spurting out, like spraying out of the bottle, carrying, you know, HCl with it, you know, on my hand and that. That's why I stopped. It's stinking up the place.